Dear students, today our lecture is about supervised learning, which is part of our course Artificial Intelligence. First we will look at the overview of the lecture. In the start we will recap our last lecture, which is types of machine learning. Then we will look at the objectives of today's lectures. What is supervised learning? Today's main topic. What are the different components of supervised learning? Then we will look at a type of supervised learning, which is classification. And then we will see what are the different steps involved in a supervised learning problem. And then we will see what we will study in the next lecture. And at the end we will look at the lecture summary, and then you will have a chance to ask questions. So what are the learning objectives of the today's class? Explain the concept of supervised learning and its core components. Understand the concept of classification, which is a type of supervised learning. Identify common real-life applications of supervised learning, and describe the basic workflow of supervised learning model. So in the last lecture we studied about what are the different types of machine learning, which is supervised learning, unsupervised learning, and reinforcement learning. And today we will specifically focus on supervised learning. So supervised learning is a type of machine learning where we need to have the labeled data sets. If we don't have labeled data sets, then we cannot use supervised learning. In that case, we have a different type of machine learning, which is called unsupervised learning. We can use that. So what is the objective of supervised learning? Predict outputs, labels from new unseen data. So the model is trained on data which already has labels. These labels are provided by some experts in their domain, depending upon what type of data we have. And then we provide new data which is previously not seen by the model, and it tries to predict the class or a specific number based on what type of basically supervised machine learning has different types that we will study later on. So there are some examples here, real life examples where supervised learning can be used. Is, for example, when we get emails, they can be spam or normal emails, and you normally use, for example, any email, for example Gmail. You know that some of your emails goes into spam folder, and the others that are normal comes to your email, right? So what is happening behind that? So they are actually using a machine learning algorithm which has learned based on data that what kind of emails are spam and what are not spam, right? So this is basically classification. And then we have another type of supervised machine learning where we try to find a continuous value. So if you see this example, we have different type of houses. They have different size of they have different number of rooms, and this is the price, how much. So if, for example, based on data, if you want to predict another house, for example, which has 4 rooms, and we want to predict the price, so at what price we should sell our house, so we can use regression. In regression we find a single continuous value. Okay, so now that you understand what we are doing here in supervised learning, can you give me another example of supervised machine learning where we can use supervised machine learning for example, classification or regression? Nice, Sar, you are right. So we can use them in those problems as you mentioned. Let's move on. So what are the key components of supervised machine learning when you have data, right? So these are parameters For example, these are independent variables, and then we want to find the price of the house. So that value is dependent on these values. So we say it is a dependent, where y is a dependent variable on x. We have x1, x2, x3. We have different properties of the house, different fields, and based on that we have a price. So these prices, we call it label, or we call it dependent variable, right? So this is also known as a feature vector, right? And if we don't have these labels, we won't be able to use supervised learning, because we have to train our model that if we have these parameters, then this is the output based on those values. So if we don't have these values, we cannot use supervised learning. So that is the main point here, right? Which is also called label, right? Okay, now we look at a specific type of supervised learning, which is called classification. So what happens here, that we have to divide our data or categorize our data into groups. For that purpose, we use classification. Our model has to learn a slope here to classify. In this case, we are separating these circles and squares. This is called binary classification, because we are dividing it into two classes, and here it's a multi-class problem. We are dividing it into three groups. So it's multi-class classification. So what is the general workflow of supervised machine learning problem? When you have data, consider that our data is clean and it's ready. So what we will do, we divide the data into training set and test set. Remember, in training set we also have labels, but in test set we don't have labels, right? Here we have labels, but here we don't have labels. If we have them, we have to remove them, right? Then we train our model on the training data. Once our model is trained, we test our model based on the test data, which doesn't have the labels. So this is trained because we have labels. Here we don't have labels, and it has to tell us the labels, right? Label is like the answer, which class it belongs, and then at the end we have the result. So the trained model make predictions on the test data. So this is basic workflow of supervised learning. So in today's lecture, we studied what is supervised learning, what are the different components. We studied a type of supervised learning, which is classification. And then we looked at the steps involved in supervised learning workflow. In the next lecture, we will study another type of supervised learning, which is regression, where we find a continuous value. At this point, I give chance to my students to ask questions. So here they can ask questions. And my philosophy is that we should interact with the students continuously, ask questions from them, and I'll also allow them to ask questions. And it needs to be a comfortable environment in the classroom where they can involve in the discussion so that they understand it better. And my another philosophy is that we need to tell the practical applications of all the theoretical topics we study here. Thank you.